Okay, in this video we're going to look at composite functions. Now, a composite function is when two or more functions are combined, so the output from the first function becomes the input to the second function. Okay, so if we consider two different functions, we have f of x and we have a g of x function. So that's a general way how to do it. You could also have an h of x as well, but f of x and g of x are the ones we're going to be looking at here. So f of x, which could be any function of x, g of x can be any function of x. So we're going to look at how basically composite functions, generally, not always, but generally, the order in which you combine them matters. So let's look at this. If you have f g of x, that means you do the g first, the g function first, and then you do the f function to it. So you put your x value into your g function, and then whatever you get for that, you put it into the f function. So f g of x means, so the g function was 2x plus 1. So if you put x into 2x plus 1, you just get 2x plus 1. And the f function was cubing. So that means your 2x plus 1 goes in, and then it gets cubed. So if I was doing this myself, if I was writing this out, I would say f g of x, just to show you how it's very hard to see from here, how you work this out, come to this point. But I do my g first. My g is 2x plus 1. And then I do my f. My f, remember, was cubing, so whatever your g of x is just gets cubed, and that's it. So just to write that out again, I do my g first. G was 2x plus 1, and then my f was cube, so it just gets cubed. Dead easy. Okay, let's look at how that's different. So same idea. If you did g f of x, you would do your f of x first. F of x is just x cubed. And then your g function is do 2 times the thing and then multiply by 1. So this gets multiplied by 2, and then 2 times the thing and then you add 1. So then that just works out to be 2x cubed plus 1. So you can see all we've done is we've changed the order in which we perform the functions, and you get two very different looking answers. Okay, so note g f of x is not equal to f g of x. Okay. Not always equal, so there are times it can be equal, but generally it's not going to be. And for g f of x, the range, so the output of f of x is the domain of the input of g of x. So where your f of x finishes is where you have to start then. That's because that's what goes into the g function when you do it this way around. If that was reversed, if it was f g of x, it would be in the range of g of x is the domain of f of x. Okay, right, going to look at 1, 2, 3 examples in this just. Okay, example 1 says if f of x is equal to 2x and g of x is equal to x squared minus 1, state f g of x and g of x. So if we do this, first of all, just write down f g of x equals. So this means, remember, you're doing your g first. So there's your g, write down your g, and then you're doing f to it. So what is f doing? It's multiplying the thing by 2. So that all just gets multiplied by 2, which is just going to be, I'll just write it out as 2x squared minus 2. Probably didn't need to write that out. Doesn't really make not a big difference, big improvement from the first line, but it's fine. Then g f of x means you do your f first. So whatever your f is, it was 2x, and then we're going to do g to it. So what g was doing, it was squaring whatever your input is, and then taking away 1. So this thing gets squared, and then you take away 1. And if you square that, big mistake a lot of people are going to make for that is going to write down that's just 2x squared minus 1, which is wrong. Remember, you've got to square the 2 and square the x. So you square your 2, you're going to get, if my 2 would ever disappear, square your 2. Bear with me. Square your 2, you're going to get 4, and then square the x, you're going to get your x squared minus 1. So again, you can see one of our functions is 2x squared minus 2, the other one is 4x squared minus 1. So again, quite different. Right, we're going to look and give the range of each for the domain minus 2 to 4. So the range of fg, it belongs to your set of rails, such that, so right, how we work this out then. So this is our equation, and if you put, we'll just put it's not always that you just put the outer limits into this thing. We'll see why. So if you put in minus 2, for example, you'd get 4 times 2 gives you 8, minus 1 gives you 6. If you put in positive 2, it would give you 4 times 2 is 8, minus 1, which gives you 6 as well. So the upper limit is 6. Okay, but the lower limit happens when you actually put in 0 into it. 0 is within our domain. When you put in 0, you're going to get 2 times 0 squared, and then minus 2, which is minus 2. So can you just make a wee note of how we have come across that one? That was 2 times the 0 squared, and then minus 2. And how we got the 6, well, it was either one of them, but we'll just go for the positive 2. 2 times positive 2 squared, minus 2. And your range for the other one then, which was, what was it, GF, range of GF. GF belongs to your set of rails, and let's see what it's going to be. So again, we're going to put in, I'll put in 0. I know this time it's going to work with a 0, so put in 0. 0 squared is 0, times 4 is 0, minus 1 is minus 1. And then we'll put in 2. 4 times 2 squared is 4 times 4, which is 16, minus 1, so is going to be 15. So there's my range. So tricky enough wee question, just be careful on those. Okay, in example 2, first thing we've got to do is find f g of x. We've got your f of x function and your g of x function. So f g of x just means do your g function first, which was the square root of x, and then do your f function. Your f function was multiply something by 2, and then take away 1. So that's your f g of x done. What we also have to do for each of these is state the domain. So for this one, we'll just say the domain is such that x belongs to the set of rails, such that x, and we just need to check the original domains for both these functions. X is greater than 0, so it can't be anything less restrictive than that. I should say. So we have to see what would work in this function. So if you put in something which is positive, greater than 0, you can have the square root of x. So it's absolutely fine. So it's going to work with that domain of x is greater than 0. Okay, as we'll see in the next example, that's not always going to be the case. Now what we're going to do is find g f of x. So that means you do your f first. Your f, remember, was 2x minus 1. And then your g function was square rooting. So that's what we get for your g f of x. The domain for it then is a wee bit trickier. So we're going to just have we think about it. So x definitely belongs to the rails, but there's going to be an extra restriction. So it's going to be more restrictive than just x is greater than 0. So basically you can only have the square root of a positive number. So we're going to have to make our 2x minus 1 positive. So we're going to have to make that positive. So that means we'll just do a wee bit of working out here. We're going to say 2x minus 1 is greater than 0, which means 2x is greater than 1, which means x is greater than 0.5. So the added restriction is x is greater than 0.5. So let's just think why that is. Let's just try it out and pick a number which is less. We'll do 0.4. So 2 times 0.4 is 0.8. 0.8 minus 1 is 0.2. Sorry, 0.8 minus 1 is minus 0.2, and you can't have square root of minus 0.2. So that's why we'll have to have x is greater than 0.5. Okay, this is a very good example of a type of question where you may look at it and think, I haven't a clue how to do the domain or the range. You can still get a lot of your marks here if you can do the first bit, which is just finding the composite function fg of x. So I'm just going to write these out slightly differently, a wee bit awkward. What this means here means f is such that x goes to x squared. Another way of writing it is f is such that x goes to the square root of x. Another way of writing it is f of x is equal to the square root of x. Likewise, your g of x just equals sine x. What it is looking for is a composite function, fg of x, which means do your g first, which was sine x, and then square root it. Okay, we're going to have to look then at the range for this thing, the domain and the range, and see how we get on. Okay, your g function we had to do first, remember, and its domain was 0 to 360 degrees. But let's have a think about this. Sine of an angle between 0 and 90, which is positive, and you can have square root of positive, that's fine. Sine of an angle between 90 and 180 is positive, and that's fine, you can have square root of positive. But sine of anything beyond 180 degrees, so between 180 degrees and 360, would be negative, so you can't have, we're not allowed this as our domain. So we'll just say our reasoning for this, and just say as sine x is negative for 180 degrees is less than or equal to x is less than or equal to 360. The domain is then going to be x belonging to the reals such that 0 is less than or equal to x is less than or equal to 180 degrees. Okay, and then the range, the corresponding range. So if you put in, and what does sine go from between 0 and 180 degrees? It goes from 0 to 1, which means if you do the square root of 0, you get 0. If you can do the square root of 1, you get 1. So the range is that fg of x is such that it goes from 0 is less than or equal to fg is less than or equal to 1. And that is the end of this video.